So, yeah, when we eat a banana, we're not eating solid potassium.
It doesn't blow up in your stomach.
Right, you're right. It would blow up in your mouth if you did that, or at least like maybe here. So what happens is you're eating compounds with potassium. Most likely, I don't really actually know the compound, but let's say potassium chloride. That's a compound. So what you're eating is actually potassium ions, so K plus ions. Those are actually really stable. And here's why. K has a configuration 2881. Because of that 1, potassium is ridiculously reactive. It wants to get rid of that 1 so it can have a noble gas electron configuration. That's what happens when it's in a compound. This is K plus 288, so it has 8, so it's stable, so it won't react. So in food, we're eating metal ions. Gatorade. Gatorade has what starts with an E?
Electrolytes.
Electrolytes. That's an electrolyte. Bananas have electrolytes. Oranges, strawberry, any fruit has electrolytes because they have a lot of ions. And that's what we're ingesting. So they're much safer and better for us. Plus, in your body you have a homeostasis. What's that? You guys with me? Okay. What's homeostasis?
Reproduction of blood cells or something like that?
It's a general term.
It's from biology.
What's up?
Can I take my test?
I don't remember what it is.
What do you need to take?
Like 2 years ago.
Oh, all elements? Yeah, right over here. So homeostasis is when you have a balance in your body between water, ions, blood. Like there's a whole balance of things in your body. Potassium ions and sodium ions are a big part of your homeostasis. If you have too much or not enough, cells can explode or cells can shrink. So you want a balance. So anyways, things like bananas, they're good for you because they help give you these things that you can lose if you don't eat them. So anyways, that's the deal with that. Hold on 1 second, I gotta get this guy a quiz.
Makes sense.
All right, good luck.
Yeah, I'm gonna need that.
Yeah. You might want to sit over there somewhere so
So
you
you
can
can
look
see,
at that.
yeah.
No, I mean that one.
Jeff likes sitting close to that thing.
Yeah, I love it so much.
All right,
So
next.
comfortable.
Okay, random elements here. What are we talking about? Now let's talk about group 17 again. What do we know about group 17? Group 17.
The least reactive?
Well,
Second to the last.
think of it in reverse. They're really good nonmetals, so they're the most reactive
Most reactive
nonmetals.
nonmetals.
Right. Most reactive nonmetals. What'd you say, Jeff?
Second to the last is what I said.
Okay, yep. So group 17, most reactive nonmetals. We should have already written that down. Maybe I'll write that again. Most reactive nonmetals. Most reactive nonmetals. How many valence electrons do they all have? You should still have your periodic table out. You don't have. Don't put those away.
Wait, don't put those away? Is that what you said?
No, I said don't put those away.
Oh my goodness.
7. So, group 17, they all have 7 valence electrons. That's also why they are so reactive, because the goal is to get 8. And group 1 has to lose 1 to get 8. Group 17 has to gain 1 to get 8. So, let's think about that. Actually, you know what? I'll show you this video right after this. If you take Na, which is 281, and Cl, which is 287, if you put those together, guess what they do? So you have sodium and you have chlorine. You put it together, guess what happens?
They
react very violently. They make salt. Watch what happens. If Na loses this electron and gives it to Cl,
it's 8.
they both become 8. 288 and 28, and everybody's happy, and you form salt. So,
And it doesn't kill you.
So
right.
So when 2 elements combine, they just balance each other out?
Yeah, when 2 elements, that's a good way to say it. It's a little more complex, but yep.
They trade a little bit.
They transfer electrons or they share electrons so that they're balanced.
So they're balanced electrons.
Shit, it's confusing.
Yeah, so they get to be stable. Yep. That's why compounds don't hurt us really as much as pure elements. Pure elements are much more reactive and can hurt us. That's why you don't go around, chewing on lead pipes. Because it's pure lead. Okay? A compound with lead actually would be probably less harmful than just pure lead. But either way, it's bad. Yeah. All right, back to this.
To their brain.
So, your hair will fall out. Well, that's mercury. Actually, any heavy metal. But anyways, back to this. Just like group 1, you can't walk down the street and find any halogens. These are called the halogens, remember? Why not? Because they're really reactive. Where do you find them? Compounds. Only found in compounds. Same thing as group 1. Only found in compounds. Why? High reactivity. Just what I said here. They want to form that 8. High reactivity. High reactivity. And oh, it's the only group on the periodic table that contains all 3 phases. What does that mean, 3 phases?
Solid, liquid, and gas.
Right, you have F and Cl are gases, Br is a liquid, I and At are solids. Contains all 3 phases. And we've got a lot of stars here today. I want to show you this hopefully today. What do we go to, 52?
Yep.
Alright, yeah, so after this, I'll show you this video of these 2. I'll go back and show you iodine. But there is some things about carbon I want to show. Whatever. We got time tomorrow. Okay, iodine is special. Iodine goes directly from a solid to a gas. It skips the liquid phase. So imagine you're holding an ice cube and it doesn't melt, it just vaporizes. That's what iodine does. What's that called? You might have heard it in your travels through school.
Skipping.
Starts with an S. Iodine can sublime.
Oh, yeah.
Yeah, that's kind of right.
Oh
Sublime.
yeah, Sublime. I like them. They got some good tunes.
That's old. That's like
It
when
is
I was in
old.
college.
Oh yeah,
Stuff.
you were saying that.
Yeah, you did. Yeah, you did mention you're like it's a band.
Oh yeah,
And
that
nobody really
worksheet.
caught it.
Yeah, yeah.
But yeah, Miss Miletta. That's it.
Yeah, Miss Milano, she's always good for the bands. Iodine can sublime. What that means is it goes from a solid directly to a gas. It skips the vapor phase or liquid phase. Skips the liquid phase. You see this in the wintertime. Where? Maybe you don't pay
Oh
attention.
yeah, you
but-
told us. You told us. Snow.
Yeah.
Yeah.
Snow. When the sun hits the snow,
It
sometimes it
evaporates?
just evaporates. It skips.
I
doesn't
never
melt.
see it though. Like I never.
If you see if you see a big bank, a snow bank, and it's maybe a little bit of a warmer day, you will see obviously water. But if you look at the top of the snow bank, sometimes you can see steam essentially coming off it. That's because it's going right from the solid to the gas. And that's hold on one second. That's how you ever get freezer burn on anything
Yeah.
in the freezer. That's what's happening. It's going from solid, it's evaporating, and then turning into a solid again. So it's kind of doing both, and that's where you get the freezer burn. Yeah. I think this is something. That was you?
Yeah,
Okay.
I forgot.
Sorry. All right, let me show you this video, then I will show you
It was
iodine.
dry ice. That's what it was.
Dry ice does the same thing. Yep. Solid carbon dioxide will go right from a solid to a gas.
Can something go from a gas straight to a solid?
Yes, that's called deposition.
I've never seen it ever.
Only these, I'm going to show you.
Okay.
But you might have to wait till tomorrow to actually see it. I'll just explain it. All right, lights please. Let me show you this video. Because I don't have chlorine gas to show you myself.
Started saying this is like can't say that.
I suppose you don't have any homework.
Yay! This is why I still like this kid. Yeah, have kid. I was talking in a study hall about what I consider.
We've asked Lonnie to demonstrate the formation of an ionic bond. In this case, the bond between sodium and chlorine in sodium chloride. So Lonnie's filled a beaker with elemental chlorine. That's chlorine gas, cl2. It's a yellow gas.
Stay.
He'll also use solid sodium metal. Solid sodium metal is a shiny silver metal that's very soft. You can actually cut it with a knife. Sodium metal is very reactive. It will react enough to initiate the chemical reaction.
He says a whole lot of stuff that might just distract you, so forget it. He's gonna say a lot of kind of mumbo jumbo. In here is chlorine gas. He's warming up the sodium metal. Why would he heat it up?
So expand? More reactive.
Yeah, it expands, but it gets more reactive. Figured it out?
Yeah.
What was it?
I had to file it a little bit.
Yes, that top piece, right?
I filed it with a file.
Because it was coming down too far.
It's like getting stuck.
Oh, sorry.
Come on, man, explain.
Yeah, what's going
Back
on?
to this. Sorry.
I don't know if it's gonna last forever, but
All right, well, we'll see. Thank you. So yeah, he's burning the sodium, heating it up so the particles are kind of, well, what do solid particles do?
They expand when they're heavy.
When in a solid, if you were to zoom in, do the particles move around in the solid or just kind of sit
No,
there?
I sit there.
They sit there and they actually vibrate, okay? So, but if you heat them up, they vibrate faster, which might help them react faster. So that's what he's doing, just kind of giving it a little kickstart to get the energy
That's
high enough. So then he sticks it in the chlorine, and you see it reacts pretty violently. If I had chlorine gas, I would show you, but I don't have any. So that's a pretty violent reaction. So that's sodium with chlorine gas. Why do you think he's raising it up and down?
Because the gas.
Because the
Gas.
To come in contact with all the gas inside, not just the gas at the bottom, right? So he's kind of getting reacting all
She's
the
just
gas.
burning it all off. Is that
How's
what's
it
going on?
gonna, how long is it gonna go for?
Well, you'll see, and then it's kind of
Oh, and then we're
Interesting.
gonna smoke.
what he does.
That's for a while. Huh?
It
Is he
blows.
gonna get salt from it? I'll have to show you the iodine tomorrow, but that's okay.
Sodium and chlorine, of course, forms sodium chloride. We typically know that as table salt. And Lonnie's prepared some in advance. He has white table salt, purified, that he can show us. There it is, purified in advance from Lonnie Laboratories. And Lonnie tells me the salt that he makes in Lonnie Laboratories is far superior to any salt that you could buy in the store. So what does he have to do now? Lonnie's going to demonstrate, clearly hasn't had his breakfast this morning, that Lonnie Lab salt far superior to any salt you could buy in the store.
Only a chemist.
Thank you.
Yeah,
can do that. I'm telling you,
He finds it funny.
the chemists at college, man, those guys are like.
So that change
Cowboys.
right there is gonna like what, settle and turn into salt? Turn into a
Yeah,
pile of
there's salt. No, there was salt probably on that. Like he had like a ladle. There's salt probably on that, and it probably fell into the bottom. But you have to kind of purify it because there's going to be unreacted sodium and chlorine in there too. So you can't just open it up and start eating it, right? So, but anyways, yeah, that's such a violent reaction because of what I explained. Group 1, Group 17, they both want 8, so they get together and make that happen. All right, so tomorrow I will show you iodine subliming and depositing. And that's about it. Bell's going to ring real soon here. You might have homework tomorrow, so just not due tomorrow. And don't forget, we're going to have that quiz next Tuesday. Likes, please.